In this video, I'm going to just reiterate the difference again between linear and exponential functions. A linear function is when we add the same number every time. If we look at our output column here, basically we'd be adding the same number as it increases each time. Technically, it could decrease by the same number each time because you'd be adding a negative number, which is still adding the same number each time. Remember, that number that you are adding is also known as the common difference or the recursive pattern. The equation for a typical linear function is a sub n equals blank times n plus blank. The blank that is the coefficient of n or attached to n with multiplication is where we put our common difference or that recursive pattern. The blank that we are adding is then where figure 0 goes. That's the output when n is 0. Let's go ahead and look at this table here as an example. As you can see, we are adding the same number each time, which makes this a linear function. In fact, our common difference is 6. We are increasing by 6 each time. Let's go ahead and start by writing our formula with our a sub n. So I'm going to go ahead and fill in our coefficient of n with a 6 because that is the common difference. Now, we need to figure out what the output is when n is 0. If we are adding 6 going forward in our table, then in order to go backward to 2, 1, and then 0, we would then need to take away 6 each time. So 1 minus 6 would give me negative 5. If I take away another 6, I'm going to get negative 11. And then take away another 6 and I'm going to get negative 17. Therefore, my second blank here would be a negative 17. Now, we typically would see this written as a sub n is equal to 6n minus 17. If we add a negative, it's the same as subtracting. So that's how I would get my final answer. Remember, you can always double check that these equations work by plugging in values from your table and making sure you get out the correct output. For example, if I plug in 4, I should get out 7. Let's double check. 6 times 4 is 24. 24 minus 17 does give me 7, so it works. Now let's move on to exponential functions. An exponential function is when we multiply by the same number every time. Yes, even if you divide by the same number every time, that would still be exponential because you can multiply by a fraction. Dividing by 2 every time would be the same as multiplying by 1/2. The number that we multiply by each time is also known as the common ratio. Let's look at the formula for a typical exponential function. The general format for an exponential equation is given here. A sub n is equal to blank times blank to the power of n. Our first blank is where we will fill in the output for figure 0. Again, that's when n equals 0. What is our output? That number goes here. It's our start value. The number that we then multiply by would be the common ratio. Again, that's the number we're multiplying by each time. Let's go ahead and look at this table for an example. As you can see, the common multiplier here, or the common ratio, is multiplying by 3. If we want to work our way backward to find figure 0, multiplying by 3 going forward in our table works the same as dividing by 3 going backward in our table. So if I want to see what my output's going to be when n is 0, I need to divide by 3 going backward. 6 divided by 3 is 2. So my start value is 2. Let's fill in these values for our equation. So I'm going to go ahead and fill in 2 for my figure 0 output, and then I'm going to fill in 3 for my common ratio. So we would write this as a sub n is equal to 2 times 3 to the power of n. Again, we can double check that it works by plugging in values from our table and making sure we get the appropriate output. Be careful though, make sure you're using the order of operations when testing this. We need to make sure to do the exponential part first before the multiplication because of PEMDAS. So if we want to plug in 3, 3 to the third power would give us 27, but then 27 times 2 does indeed equal 54. So it works.